So in our last video we talked about completing the square. Now we're going to talk about using that concept to solve an equation. So the first example here is going to kind of be, we're working backwards. This is what it's going to look like after we complete the square. We're already going to have a perfect square binomial equals something. Once we have that, we've completed the square. That's this part here. At this point, it's solving an equation. Remember, solving an equation, I need to get x by itself. So I have something squared equals 100. The best way to solve that is square root both sides. Because square root and squaring cancel each other, that's going to cancel my radical and my exponent of 2 here, leaving just x plus 5 on the left-hand side. However, what you have to be careful here, when you square root both sides of the equation, this is saying what times itself equals 100. There's actually two answers to that. Because the square root of 100 could be positive 10, which is what most people would think, but it also could be negative 10. So what you might sometimes see is people write this as x plus 5 equals plus minus 10. I'm not going to write it that way because that's really hard to solve. People don't understand what that means. What that means is that x plus 5 could be 10, or x plus 5 could be negative 10. These are situations when we actually have two different equations to solve. It's just a linear equation at this point, so I can subtract 5 from both sides here. I can subtract 5 from both sides here. I'm going to have two possible answers. X could equal 5, or x could equal negative 15. Those are two possible answers to this equation. Every time you square root both sides, you're going to have this situation. Use that as an example to try this problem on the right. Please press pause and try it. It's a very similar problem where you do not have to complete the square. Alright, this is just our first step. I square root both sides. All that changes on the left is my square root and my exponent cancel, leaving me the x minus 2. But the square root of 121 is either 11 or negative 11. It has to be two equations. One equation is not going to be good enough to get credit on this type of problem. At this point, you solve and get x equals 13 or x equals negative 9. Okay, like I mentioned, we are kind of working backwards here, so now we have to go back to completing the square. This example doesn't look anything like we had up there, but we're going to make it look like that. Okay? And the key to doing it in that way is we want to focus on our x squared term and our x term. We want those to be isolated on the left side, x squared plus 6x, but I want to move my constant term to the other side of my equal sign. This is kind of contrary to what you've always been taught before. But I'm going to add 72 to both sides. And that's what I wind up with. You don't need the positive, you can just leave that as 72. And I'll make that in a different color just because we're going to do something here that's going to be an important idea. Here's why we complete the square. This serves pretty much exactly like the problem we did on our previous video. I can use the x squared and the 6x to complete my square. So I need to find what I would add here to make this a perfect square. Well, that's when I do 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. That means if I add 9 here, this is now a perfect square, which would be factored as x plus 3 squared. That's why we completed the square. Now I have the beginnings of this equation here. I have a binomial squared. The trick here is I'm not done because I added 9 to the left side of my equal sign. And we all know from algebra, you cannot do something on one side without doing the exact same thing on the other. If I'm going to add 9 on the left, I have to add 9 on the right. It's the only way to make this work. 72 plus 9 is 81. We have just successfully taken this equation and rewritten it this way by adding 9 to both sides, completing the square. I now can solve this equation here, same way we did in the previous example. Square root both sides. Square root and exponent of 2 cancel. I get x plus 3 equals. I'm square rooting both sides. That means square root of 81 is positive 9. Or I have to solve x plus 3 equals negative 9 as well. Subtract 3 from both sides, and x equals 6. Subtract 3 from both sides, and x equals negative 12. That's one example. Let's take a look at example 2 together. In this case, I don't have to worry about separating the sides. I already have my x squared minus 12x on one side, and I have my constant of negative 20 on the other side. I don't have to do any pre-work with the algebra. What I want to do now is complete my square. I'm going to take negative 12 divided by 2 and square it. That's negative 6 squared. That's positive 36. I add 36 then to both sides. Can't do it to just one. We got that number because I want to complete that square. Okay. And I have x minus 6. Here's my minus 6 here. Square root, x minus 6 is 4, or x minus 6 is negative 4. Okay, those cancel. Square root of 16 is positive or negative 4, so I get x is 10, or x is 2 as my final answer. 4 problems for you to practice here. Please go ahead and try them. I'll put the first 2 answers up and talk about them briefly, then put the second 2 answers up. Hit pause and try them, please. So these were similar problems, and they both were set up already where we just needed to complete the square. So negative 8 divided by 2 is negative 4. If I square that, I get plus 16. That's what I add to both sides. Ooh, and I did make a mistake. Let's fix that. That should be x minus 4 quantity squared equals 25, which makes it x minus 4 equals 5, which would mean x equals 9, or x minus 4 equals negative 5, which means x would equal negative 1. That's why you work through it. You can catch your own mistakes. And in this one, it was also set up 14 divided by 2 is 7, squared is 49. That's what I add to both sides. X plus 7 squared equals 1, so x is negative 6 or negative 8. If you haven't tried 7, go ahead and try it. I will do example 3 with you. So in this example, we do first have to make sure that we have standard form, or our x's are all on the left. We already had x squared, but I had this minus x on the right. To move it, I add x to both sides, combine my like terms. Then I had x squared plus 2x equals 3. I could complete the square on the left by adding 1 to both sides. Perfect square binomial, square root both sides. Example 3 is different. I told you on our previous video that all we would do is leading coefficient of 1, and this doesn't have that. So in order to make sure we get that, we want to divide everything here by this coefficient of 2. We want to get just a 1x squared, but we can't do just everything on the left. You have to do everything on the right as well. 2 over 2 leaves me with just my 1x squared. 20 divided by 2 leaves me with minus 10x. 342 divided by 2 leaves me with, that's a minus, 171. And that's equal to 0. At this point, it becomes kind of like my first example from before. I need to get this negative 171 onto the other side. So I'd add it to both sides. X squared minus 10x equals 171. I can now complete my square. Negative 10 divided by 2 is negative 5. If I square that, I get 25. So plus 25 and plus 25. Since that divided by 2 was negative 5, that should tell you you have an x minus 5 squared. And that equals 196. Which means x minus 5 equals square root of 196 is 14, or negative 14. And when we solve, we get positive 19 for x, or negative 9. On our next video, we will start talking about circles, and we'll see how we can apply the idea of completing the square to writing the equations of circles.